it says factorize completely the following quadratic. When you factorize in the quadratic expression, we employ the AC method. So let's look at this. A is equal to 5, B is equal to -9, and C is equal to 4. From this, we're seeing that AC, which is equal to 5 times 4, is equal to 20. All right? So then we're saying that, guess what? What are the factor pairs of 20 that could give 9? It's the same 5 and 4 here. So we're going to be using about 5 and 4, but we're going to be using -5 and a -4, because this will give us -9 if we add them, and if we multiply, we'll get +20. So then we're suggesting that it's 5x squared minus 5x minus 4x plus 4. We're going to group them in pairs. 5x is what I'm going to be using here. 5x into 5x squared, that is x. And 5x into -5x is -1. -4 into -4x is x. -4 into +4 is -1. Now, the fact that my two brackets, as you could see here, would have been the same thing, then I could factorize again. So I'm going to isolate this, and then the other two things on the outside, which are 5x and the -4, would go into the other bracket, and I would have captured my 2 marks there. So my response could be x minus 1 times 5x minus 4, or it could be 5x minus 4 times x minus 2. So whichever one of those, we would have ended up, getting the answer. Now the question went further and says, hence, solve the following equation, which is the same quadratic expression now. To put the equal 0, turn it into an equation. Whenever you get the word hence in a mathematical problem, it is suggesting that you must use the answer you got just now. So it simply means then we would just say, guess what? X minus 1 times 5x minus 4 is equal to 0. And the fact that I am multiplying two things and I get a 0, at this moment I can say either x minus 1 equals 0. If I add 1 to both sides, then x is equal to 1. Or 5x minus 4 is equal to 0. So we're adding 4 to both sides. 5x is equal to 4. Divide by 5, then x is equal to 4/5. So there it is, I have my two solutions. X is equal to 1 and x is equal to 4/5. All right, for those. The next question that came was a algebra question that says, make V the subject. All right, so make V the subject. So what we're going to do here is to get rid of the fraction, because we have a fraction thing going on here. So basically, let me start by writing this. We have W is equal to 5 plus V over V minus 3. We want to multiply both sides by the V minus 3. So I'm going to have W times V minus 3, which is equal to 5 plus V over V minus 3. And I'm multiplying that by that. I did it because the V minus 3 could cancel itself on the right side. But on the left side, I am going to have to distribute the W inside the bracket so that I could expose that V. So what do we have here? Well, we'll have V times the W minus 3 times the W. And this is equal to 5 plus V. I want to gather the V's on the left side. I want to do that. So it means then when I shuffle this, I would have to basically add 3W for it to go on the other side. So I'm going to balance by adding 3W to the other side. I would have to also subtract V from this side and have to balance by subtracting V from that side. So I'm reorganizing myself. So basically, I'll have VW minus V, which is equal to, because this piece becomes 0 right now, right? So this is equal to 5 plus 3W. Or you could say W, you could say 3W plus 5. Doesn't matter how you put that, that's fine. Any one of those, good to go. The final step now, I'm going to factorize V because V is what I want to be the subject. So if I factorize out the V using the highest common factor, I'll have W minus 1. Finally, 5 plus 3W. I'm going to divide by W minus 1, divide by W minus 1. Let me write my final answer here. So when this cancels, I'll have V, which is equal to 5 plus 3W, or you could say 3W plus 5 if you want, all over W minus 1. So there it is. We would have gotten that response. All right. So there it is, our transposition. Wonder how many persons here got that transposition right. Lopez, you get that? Mr. Layla? Got that? All right. All right, let's continue. Let's continue working. All right. This question says, the height h of an object is directly proportional to the square root of its perimeter P. So this is a variation question. Remember though, the variation questions, you have to just read what they're saying. So we're just gonna read. We're saying that h, all right, the height h of an object is directly proportional to the square root of P. So we're talking about h, talking about the h and the P. And then I am going to use a K from a constant. Basically, they are saying to write an equation to show the relationship between h and K. It starts off by saying h is directly proportional to the square root of P. And that is how simple you put that. Normally, this is like a 1 mark question. You could see it's just 1 mark here. So it's not a lot of work. H is equal to K times the root of P. And we have that. We're good right there. Right there. We're good right there. All right. Now, the next question though says, given that h is equal to 5.4, when P is equal to 1.44, determine the value of h when P is equal to 2.89. Let's write back our formula of the day. The formula says that h is equal to K, yeah, times the root of P. Now, in order to solve this problem, we have to find a value for our constant of variation K. What we're going to do, though, is to substitute h and P in the known situation to find K. Therefore, h is 5.4, and this is equal to K times the root of P, which is 1.44. Now, 5.4 is equal to, let's find the root of that. So the root of 1.44 will give us 1.2. So we have K times 1.2. So because we have K times 1.2, we're going to divide both sides by 1.2. And then this will land us the value of K. So 4.5 is equal to K. Now, finding K will now just give us the gas we need to find P, to find H when P is 2.89. Same formula. H is equal to K times the root of P. we need to find h. So h is equal to k, which is 4.5 times the root of p. So the root of p is 2.89. So it's a root of 2.89 because p is 2.89. All right. So let us get that now. Root of 2.89, that's 1.7. So basically, h is equal to 4.5 times 1.7. So we want to put that on our calculator, yeah? And we'll get an answer of 7.65. And that is h. So that is h when p is 2.89. All right. So I want to double check to see how it goes. How many of us got that? Huh? How many of us got that? All right, not sure. All right, we're still going at it. Still going at it.